Okay, I've decided to stop explaining things I don't understand and go back to the things that I actually understand. So let's go back to fundamentals of computer data structures. Today, let's talk about the good old classic linked list. So here's the thing. Linked list comes from the problem of memory. You can look at your system and you know that your RAM is actually just one massive array. It's a whole contiguous chunk of free space. So think about it like a piece of, it's like a receipt. It's like a really long receipt. And like each line of a receipt is like some data, like, oh, fish balls, eggs, and then you just put it into the receipt. So in the sense of receipt, it makes sense because each line is just one line, one element. It takes up one space, one unit of space in your paper. But the issue with RAM is that sometimes you're not just doing one line. You can be doing a whole section of data. And this is called contiguous memory allocation because you're allocating one contiguous or continuous memory, like region of memory. So this is called contiguous. Why am I lagging? Contiguous memory allocation. So what this does is, what does a linked list try to solve? So first thing, why linked list? Oh man, I can't write. So a linked list comes in handy when you have this thing called data fragmentation. So imagine this, we have this long receipt and we just want to keep adding things from the top. So we can add some stuff here, add some stuff here, we can add more stuff here, and then like so on, we add even more stuff, and then we get to this point. Okay, pretty cool, right? So let's say I can suddenly free up this space. I can delete the space. I delete the items from my receipt, and then let's say I delete some stuff here as well. So I now have like two free empty spaces here and here that I can use. So let's say somehow I filled up all this other space, like oops, I used it all up, and I'm only left with these two items here. And I have another item that's around this big. This item is too big to fit in any of these two. It's just too big to fit them. So if we allocated it as a contiguous chunk, we could not fit it into the memory. However, what if we, where's my cursor, split it into two parts? And so now the first part can go to the first piece of memory, and the second part can go to the second part of memory. And now we have broken the data down to chunks, and we can fit it into the array or into our memory. This is the core motivation behind the linked list. We want to break things down so that we can fit things into tight spaces. So the next thing is how linked list with a why. Now we need a how. And I would how the moment I can write with this tablet. Okay, how. So the core crux, the core structure, is using something called a pointer. A pointer is like a finger. You point at something and then you know where the next thing is. I can point at the camera and you can know that the camera is there, which is what I'm pointing at. In a similar fashion, if I can find my cursor, a pointer goes from one object to another object. It points like an arrow, it points like this. So there's a section of the object that is dedicated to pointing at another object, and this object can also point at another object. like so. That's actually not accurate. We should point to the start of the object because that makes a lot more sense. Oh, yikes. Okay. Oh, the lag is unbearable today. Jeez Louise. Okay. So yeah, that is where our linked list comes from. It's called a linked list because it's like a chain link. Each item is linked to each other, and this way we have a list that is linked together. And so how does this fit back into the fitting into small spaces thing? Well, each of these items could be very, very small, and thus we can slip them into small pockets of memory. However, due to the pointer, we can actually have the next item anywhere in the list. So let's say we use this array again. See if I can find my cursor. Yeah. So we can use we can fit a lot of the small entries here. Like a lot of them just go into there. And then when we need to point to an item because we ran out of space, we just point it, and then it goes to our next item here, assuming it catches up. Yeah. So this, you can sort of imagine how with enough pointers you can just fill up every small bit of space that can fit each individual item in the linked list. So that's the main benefit of a linked list, is that you can use it in very fragmented spaces. A quick drawback before I end off is that each going through the pointer, like following a pointer, is quite slow. It's like, let's say you have a chain of people in real life, and I'm pointing at next guy, he's pointing at someone else. You have to follow the entire chain to see that who the last person is pointing at. However, if everyone's in a straight line, you can just run to the end and just see who the last guy is. Similarly, if you had a contiguous array or a contiguous list, you can just jump to the end if you knew the size. So you could just do something like you could just start from here. That is not here. You could jump from here to here in one step because you knew that that's the end of the array, that's the last element. However, if you had a linked list like the one on our right, you can't tell at all where it's supposed to go unless you follow the entire array. So yeah, that's a quick crash course in the linked list. Hopefully I explained things clearly, and yeah.